Alright, this is going to be a quick follow-up. I got my first day's run in on solar panels with the WattsVIEW meter, and it generated about a 2 megabyte file, which I imported into Excel. It has actually 37,000 lines of data in it, and you can see it's generally about a half a second per data point all the way up to the beginning. And so I took that data, and my date and time is incorrect on my laptop, so to ignore that, but it collected the and this is right off the file. You just bring it in as a tab delimited text file. So it's a text file on the on my memory stick, and then I just open it up in Excel, and it automatically recognizes it as tab delimited and opens up in these nice columns. So then it's pretty easy to create a graph. Unfortunately, Excel only takes 32K in that it can plot at one time, so you have to kind of plot two data lines on the same chart to get the two different readings. But you can plot voltage, amps, watts, whatever you want. I decided just to make the graph cleaner, I would just do the watts. And I have about 140 watts of two panels out there that I connected up today for this test. And you can see it started off in the morning in about 50 watts, and then stayed pretty steady through the day. And we started to get some choppier sun up to around noon, and then we pick up over here on this green line here at around 110 watts, and then it started to get a little more intermittent, and finally the high clouds came over and we started to tail off down into the 20s, and we're just starting to get a little bit more break in the sun here late in the day. But anyway, this is kind of representative of the kind of graph that you'll be able to plot on a daily basis. There's also, you can take the collected watt hours, and this is kind of like the area under the curve. This is how much you really are actually capturing, and should be able to compare that to what you're putting through on your grid tie inverter minus the efficiency loss through there, and see how you're doing. So anyway, it's pretty neat. So just in today's little collection, and it wasn't the whole day, did a third of a kilowatt hour on those two panels out there. Alright, just one little follow up here. If I take this end time here at 8:52 and subtract the beginning time from it, it tells me the total time that I ran the logging, which was 6 hours. So I just put a rough number 6 in there. Then I take the watt hours that were accumulated through the whole logging process, which was 333. Divide that by 6, tells me that the average watts per hour was 55.6 for those two panels. So if I go back over to my chart, and I already put in this line here right at 55.6, and you can see it's pretty accurate. So below the morning, it was start off below it, but then went above it, stayed above that line till noon or so, pick up over here, stayed above it, and then a lot of the time this afternoon was spent below that line, quite deeply below it, giving it that average. So anyway, that's one cool way that you can use the data coming off of this system, tell you really about what you got for the whole day graphically.